Hello friends, welcome to EC Academy. In this lecture, let us understand the circular convolution property of DFT. Now let us write this statement. If DFT of x of n is equal to capital X of k, then we can write DFT of y of n, which is a new sequence, will be equal to x1 of n with a circle. This is circular convolution representation. x2 of n will be equal to y of k, that can be written as x1 of k into x2 of k. So here n with a circle represents circular convolution. This can also be written as star with circle. So both are same. So you can write star with circle or n with a circle, that represents circular convolution. So here the circular convolution of x1 of n with x2 of n will be equal to x1 of k into x2 of k. Let us prove this. Let us take the proof. Let us take y of k, that will be written as x1 of k into x2 of k. IDFT of y of k, we can write it as y of n, that can be written as 1 by n summation of k is equal to 0 to n minus 1 y of k into e to the power of j 2 pi by n into k n. So here y of k is equal to x1 of k into x2 of k. Let us substitute in this equation. So we can write y of n will be equal to 1 by n summation of k is equal to 0 to n minus 1. Y of k is x1 of k into x2 of k into e to the power of j 2 pi by n into k n. We can write x1 of k as summation of m is equal to 0 to n minus 1 x1 of m e to the power of minus j 2 pi by n into k m. So instead of n, we are writing a term as m, because we have already used n here. In the same way, we can write x2 of k is equal to summation of L is equal to 0 to n minus 1 x2 of L e to the power of minus j 2 pi by n into k L. Let us substitute the value of x1 of k and x2 of k in this equation. We will get y of n will be equal to 1 by n summation of k is equal to 0 to n minus 1. Let us write this summation. Summation of m is equal to 0 to n minus 1 x1 of m e to the power of minus j 2 pi by n into km. We will write this in place of x2 into summation of L is equal to 0 to n minus 1 x2 of L e to the power of minus j 2 pi by n into kl into e to the power of j 2 pi by n into kn. Now let us rearrange this equation. So rearranging the above equation, we will get y of n is equal to 1 by n summation of m is equal to 0 to n minus 1. So we will write this term first. So it is x1 of m into summation of L is equal to 0 to n minus 1 x2 of L into summation of k is equal to 0 to n minus 1 e to the power of j 2 pi by n. So we will take e to the power of j 2 pi by n common in all these terms. So it will be So from this we can write n. So from this term we can write minus m, and from this term we can write minus L into K. Let us call this as equation number 1. We know that summation of K is equal to 0 to n minus 1. Alpha to the power of K can be written as 1 minus alpha to the power of n divided by 1 minus alpha for alpha not equal to 1, and this summation will be equal to n for alpha value equal to 1. Here if we take this bracket term and relate with this equation, we can say alpha will be equal to e to the power of j 2 pi by n into n minus m minus L. If we take L is equal to n minus m, if we take L is equal to n minus m, at that case if we put n minus m in place of L, we can write n minus m minus n plus m. So we can cancel out all these terms. So this term will become 0. So e to the power of 0 will be equal to 1. So at that case we can say alpha will be equal to 1. So alpha will be equal to 1 when we make L is equal to n minus m, and alpha will not be equal to 1 for L not equal to n minus m. Let us use this analysis in the above equation, and we can write in place of alpha we will write this term. So we can write 1 minus e to the power of j 2 pi by n into n minus m minus L into n. So whole to the power of n, if we take inside the exponential term we can write into n divided by 1 minus e to the power of j 2 pi by n into n minus m minus L. If we cancel out n, the remaining term will be equal to 1. So 1 minus 1, it will be 0. 0 divided by any term, it will be 0. So this will be 0 for L value not equal to n minus m. So if L value is not equal to n minus m, at that case alpha value is not equal to 1. If we take L is equal to n minus m, at that case the above formula will be equal to n. So for L is equal to n minus m, we will get n. For L not equal to n minus m, we will get 0. So we will take this value in place of this term, and we can write the above equation as y of n is equal to 1 by n summation of m is equal to 0 to n minus 1 x1 of m into summation of L is equal to 0 to n minus 1 x2 of L. In place of L you can write n minus m, because we are taking the value for L as n minus m. If we take other values for L, it will be equal to 0. So if we take L is equal to n minus m, the term will be equal to n into this entire term we have already calculated here, the value is n. Here we can ignore this summation value, because L is having only one value, which is n minus m. For other values we are getting the value as 0. That's why we can neglect the summation of L is equal to 0 to n minus 1, because we are taking L as only one value, which is n minus m. So we can write the above equation as y of n is equal to 1 by n summation of m is equal to 0 to n minus 1 x1 of m into x2 of n minus m into n. So here we can cancel out these two n. So we will be left out with y of n is equal to summation of m is equal to 0 to n minus 1 x1 of m into x2 of n minus m. So this is the formula for convolution. So this is the convolution formula. That's why we can write this equation as y of n is equal to x1 of n convoluted with x2 of n. So this is the derivation for circular convolution. Hope you have understood the topic. Thank you.